Good morning, guys. Today we are going to continue on with our coordinate graphing, but we are going to extend the coordinate graphing to rational numbers. And what we're going to start off with is this bell ringer question, because this was a question that was on the homework that I didn't cover in the last question because we ran out of time, or in the last class because we ran out of time. The question says, what is the ordered pair? That means you need to have a pair of numbers where order matters. What is the ordered pair of the reflection? A reflection is like a mirror image of the library across the x-axis. Okay, so we're looking for the library and we want to flip it across the x-axis. So let's find the x-axis. Remember, the x is like a cross, so it's the axis that goes across. So I want to flip it across this line right here. The library is going to be this point, okay? So I want to flip it up across that line. That way, if I were to fold the coordinate plane along that green line, the two dots would match up. So all I have to do is figure out where it is. So let's figure out how far below it is. It's 7 below. So that means I have to stay on this line and I have to go 7 above. Okay, they have to be the same distance from the line we drew. So if this was 7 below, this one's 7 above, they're mirror images, there's symmetry between them. So that means it is over 10, and then it is up 7. Remember, you always go over, then up or down. You got to shuffle across the carpet before you can climb the stairs. So that is the answer. A reflection is a mirror image. Always pay attention. Are you reflecting it across the X or are you reflecting it across the Y? Okay, so if you didn't finish your homework assignment from last week, that should help you along with some of these other problems we're going to do. Okay, so once again, we are finishing lesson 2 for today, which is representing rational numbers. That's the main focus today. Rational numbers on the coordinate plane. Remember, integers are things like -1, 0, 1, 2, 3, -2, -3. Integers are positive and negative whole numbers, okay, including 0. Rational numbers are going to give us decimals, things like -1/2, 1 1/4. Fractions, they can be positive or negative, they can be whole numbers, they can be decimals, they can be fractions. So now we're going to have to graph fractions and decimals. Oh me, oh my, but we can do it. So let's review our targets. The main goal is going to be able to identify and graph points. Okay, so tell me the location, giving me an ordered pair, and then graph points if I give you the ordered pair. Don't forget, we also want to reflect points across either axis, whichever one they tell us. Now, we should know how to do a lot of these things. The only new thing is what's highlighted is where we are going to plot rational numbers. But we know how to draw and label the number lines. We know which one's the X because it goes across. Y goes up and down. We know how to identify the 4 quadrants. They start in the top right and then they go backwards. We know the origin is 0, 0 where the 2 cross. And we know how to identify ordered pairs and how to go over and up or down. And we just reviewed how to reflect. So the only thing new today is going to be the rational numbers bit. So first, let's review last week's stuff a little bit more. So in class, we're doing Pear Deck. If you're watching the replay, you're going to have to kind of just do it with your fingers or pencil and paper. It wants you to label each quadrant. Quad means 4, so there's 4 sections. You need to label which section is which. So go ahead and do that now. You should have labeled it 1, 2, 3, and 4. Now, a lot of times you're going to see it as Roman numerals instead of traditional numbers. It's kind of like using eyes. 1, 2. This one's going to have 3 eyes. And 4 is shown as an I and then a V. Okay, so Roman numerals or regular numbers work. So that is how the quadrants go. They go counterclockwise. You always start where everything's positive, top right, and then you work your way around. It kind of makes CG. Looks like a C. When you put the arrow, it makes a G. Okay, now that we've reviewed quadrants, let's view graphing on the coordinate plane. Okay, it wants you to plot each of the following points. So I recommend you take your finger on the screen and do the red one first. Go 0, -5. That means over 0, up or down -5. Put your finger where it goes. And it should be here. You go over 0, down 5. Your red dot, your finger should be right here. Try the next one. -2, 4. Place your finger on your screen where you think that goes. -2, 4. And I'm going to show you the answer. If I'm going too fast, you need to pause. You start at the origin. You need to go backwards to -2 and then up 4. Remember, you always shuffle. You go side to side before you go up or down. Next one is -6, 0. Use your finger, find where that goes. Sorry, I needed a drink. Okay, you should go backwards to -6 and you go up or down 0. That's where your finger should be. Last one, find 3, 1. Find 3, 1. If I'm going too fast, make sure you're pausing. So you start at the origin, you're going to go over to +3, and then you go up to +1. So that is where our 4 dots should be. You always go over and then up or down. So now that we've graphed points, let's see if we can identify points. I think that's next. Yes, this wants to know, what is this ordered pair? So think for a second, what number goes first, what number comes second? You can write it on pencil and paper or just think it in your head. What is the ordered pair? Order matters for this graphed point. This graphed point, you always start at the origin, went over 3. So 3 is the first number. You always go over first. And then it went down to -4. Okay, remember an ordered pair goes in the form x, y. So your x value was at 3, your y value was at -4. Now the directions, it gives us another question in there. We weren't done with this. It says, what is the ordered pair for the point if reflected, we have to reflect it over the y-axis. So first figure out which one's the y. Does y go across or does y go up and down? Well, when you look at the graph, the y is right here. It is the axis that is up and down. So I'm going to try to make as straight a line as I can. I need to take this point and I need to flip it over here. But they have to be the same distance away from that line in order to be a true reflection. So this dot was 1, 2, 3 to the right. So now from this red line, I have to go 1, 2, 3 to the left. The ordered pair for the reflection is backwards 3, down 4. And remember, reflection should have numbers that look pretty much the same, but you change one of the numbers to its opposite. Okay, so this is a reflection. They're mirror images. If I were to fold along this red line, those two dots would match up. So it's reflection. Okay. Now I think we're going to do a little bit more review with just plain graphing integers before we get into rational numbers. And it's problems that a lot of people were asking about from their homework assignment. So I want to make sure everyone understands this. So it starts off easy. Which building is located in quadrant 3? Well, remember, you go 1, 2, 3, 4. So when you look at the 3 quadrants once they're identified, the only building in quadrant 3 is the firehouse. Okay, so you have to know the quadrants. So it may be to your benefit to take a piece of paper and draw yourself a simple coordinate plane, something like that, and go ahead and label the 4 different sections. That way you have that as a reference. Okay, you have a reference for any question that asks about quadrants. So it might be handy to do that. Let's move to the next question. Sorry, I know it's not very exciting watching me erase. Okay, the next question gets a little bit more tricky. It says which two places have the same x coordinate. X is how far over. I spelled over wrong. Over. It's how far over they are. So you need to find two places that are over the same amount. So if I go over to the doctor's office, here's the doctor's office. There's nothing else that was over the same amount. So let's go over to the school. Here's the school. There's nothing else that was over at 4. Okay, let's go to the swimming pool. If I go over to the swimming pool, it was over 12. Well, look, the clubhouse was over 12. These, when you draw a line through them, they were both over 12. They have the same x coordinate. They were both over the same amount. So you would pick swimming pool and clubhouse because they have the same x. They're over the same amount. That was giving people lots of fits last week. So let's go to the next one. See what's going on there. Okay, this one's a reflection problem, and I want you to see if you can figure it out on your own. It says the city council wants the location of the entrance to a new city park to be determined by the reflection of the school across the Y. So we need to find the school. Here it is. Across the Y. Y is up and down, just like how the tail of a Y goes up and down. And we want to know its reflection. So right now, figure out its reflection. Pause it until you figure it out, and then come back and get checked. So the reflection, this school is 1, 2, 3, 4 away from the line. So I need to keep it lined up, but I have to go 4 the other direction. So its ordered pair is -4 because it went backwards 4. But it has the same amount up because they're lined up. It was up 3. So that would be the entrance to the new park. Okay? So far, everything we've done is a review. So if you were confused on this review material we just did, you might need to go back and watch the lesson from last week that covers the original graphing, because all of this should be review. What we're about to start is the new stuff. So if you look at this coordinate graph, there's something different about its scale. Scale refers to like the x and y axis and what they're counting by. So look at the scale closely. How is it different from the scales we've seen before? Well, when you look at the scale, each box is not one whole. One whole is way over here. It's like skipping boxes. Here's 1, here's 2. That means each grid line in itself is a fraction or decimal part. That is where we are talking about rational numbers. So it says, what decimal part does each grid line represent? Well, let's figure out how many parts there are in a whole. So we're going to make a fraction model. From between 0 and 1 whole, each of these lines breaks up my fraction. So my fraction has 4 parts. So that means that this number line is broken up into fourths. Fourths. Fourths are things like this: 1/4, 2/4, 3/4, 4/4. It is broken up into fourths: 1/4, 2/4, 3/4, 4/4. But it says what decimal? Well, this is quarters, guys. 4 quarters make $1. 1 quarter is 25 cents. 2 quarters is 50 cents, or a half. 3 quarters is 75 cents. And 4 quarters is 1 whole. Okay? So we are going by 25s. Okay? A quarter. That is what we're counting by. So keep that in mind as we answer these questions involving rational numbers in the White House and FBI building and all these different locations on this grid map. Okay, let me click it on. So it asks us, what are the coordinates of the Jefferson Memorial? Well, first thing you have to do is find Jefferson Memorial. It's right here. So I'm going to trace it up because these lines are really faint. Okay, so that is over 1, 2. Well, that's 2/4, or if you notice, it is halfway between 0 and 1. So that is over 1/2. It's halfway, okay? And half of $1 is 50 cents. So you could write it like this. That's how far over. And then we want to know how far down that was. Oh, goodness gracious. It comes to this tick mark right here. So let's see. That's down 1 whole. Down 1 whole. So I know there's a -1. And let's figure out the fractional part. It's down 1 whole, and then 1, 2, 3/4. So it's down 1 3/4. Well, we know 3 out of 4 quarters is 75 cents. So this is how you're going to do it with rational numbers. You have to make sure that you're paying attention to your whole numbers, as well as how many little hops you go past whole numbers to get that fractional part. Okay? I'm going to erase this, and we're going to keep practicing with these types of fractional problems. It is tricky, I will give you that. Now, here's one where they give us the ordered pair. They give us 2 1/4, and we have to choose which place is located there. Well, 2 is easy. 2 is a whole number. Remember, you always go over first. I have to go over to 2, and then it wants me to go up 1/4. We said that each line is 1/4, so I just go up 1 of the spaces. So the FBI building is located there. It's kind of easier to figure out which building is somewhere than it is to give the coordinates of a certain specific building. But we do have to know both skills. Okay, let's keep practicing. Okay, this one gives us a new map, a new picture. Remember, we use coordinate planes a lot. It's like maps and graphing. How many parts is the whole divided into? Well, a whole from 0 to 1. Let's figure out what our fraction model is divided into. So each of these tick marks divides my whole up. I'll make all of my tick marks, and then I'll go back and count. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means we're dealing with tenths. Each section is a tenth. 1/10, 2/10, 3/10, and so on. So you can write them as fractions as out of 10, or you can use place value. The first number after the decimal is the tenths. So 1/10, 2/10, 3/10, and so on. Okay, so this one's just counting like up to 10, but you put it after the decimal point. So by drawing a fraction model between 0 and the whole, we can figure out how many pieces the whole is divided into. So this is based on tenths. Tenths. All right, now let's answer some questions now that we know that. It wants to know what is located at -7/10, -2/10. So right now, follow those directions. Take your finger on your screen and go to -7/10, and then you're going to go up or down to -2/10. You try it first. Okay, if I start at the origin, I have to go back to 7/10. 1, 2, 3, 4, 5, 6, 7. And then I need to go down to 2/10. 1, 2. You should have gotten the pond. The pond. You always go over first, then up or down. Shuffle across the carpet before you climb the stairs. Okay, so we're just counting like normal since it's based on tenths. Let's try another one. What is located at 3/10, -1/5? This one's more challenging, okay? Try this one. Put your finger where you think it needs to go. You want to go 3/10 and then -1/5. Hint, you may need to change this to a decimal. And we've already learned how to change a fraction to a decimal. Okay, so 3/10, that's positive. I need to go over 1, 2, 3. So then I'm going to go negative. If I go negative, if I go down, there's only one thing that is negative that's lined up over at 3/10. So it has to be the start of the hiking trail, and here's why. -1/5, if you do 1 divided by 5, it's going to give you 0.2. Okay, so -1/5 is the same as 2/10, -2/10, 1, 2. You go down 2. That is why it's the start of the hiking trail. So you can use the clue that it was negative and you go down and there's only one thing on that line, or you could have also converted that to be exact. All right, and these are going to be on your homework. So all of the ones that we're doing right now, you're going to have pretty much this exact same picture or close to it, and it's going to ask you questions about it. So I would make sure you're paying attention. This one says, write the ordered pair to locate the end of the hiking trail. End of the hiking trail in 2 ways. Okay, so let's start with fractions first. So you would go over 1, 2. So you go over 2/10. And then you would go down 1, 2, 3, 4, 5, 6, 7, 8. Down is negative. You have to go down 8/10. Now you could simplify that if you wanted and have a -4/5, but 8/10 is fine. Now, if we did a decimal, 2/10, that's just 0.2. -8/10 is -0.8. Okay, so that's writing it 2 different ways. We still follow the rule you go over and then up or down, but we're counting by tenths, rational numbers. Okay, erase, 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 erase. Next problem. I think this might be the last one. What are the coordinates of the information center? Well, you have to find the information center. It's right here. I want you to pause and see if you can find the coordinates. It didn't tell you what form, so do decimal or fraction. It's up to you. Pause it, jot it down on your paper. Okay. So we would go backwards 1, 2. So it's -2/10. And then we go up 1, 2, 3, 4, 5, 6, 7. Ooh, this is like in between. That's like 7.5. Well, how do I write 7.5/10? Okay, I can't write -7.5. Let's change the decimals instead. So -0.2, -2/10. This one was going up 7/10, so positive 0.7, and then it went halfway up. We show half by doing like a 0.5. So we're going to use 0.75 because that is halfway between 7/10 and 8/10. If you put in your invisible zeros, 75 is halfway between. What a tricky question. Okay, so that was -2/10 and then up 7.5. So those were tenths, up 7/10, and then half of a tenth is 5/100. So 75/100. So we're going to see if you can apply what we talked about with rational numbers to graphing for rational numbers. Okay, you're going to do it one at a time with your fingers since you're watching the replay. So start with the red. Move your red dot to where you think it needs to be. And once again, you're using your finger. And then when you think you have it, unpause. So the red dot is over 3/4. Well, 1, 2, 3, 4. This is divided into fourths, okay? And when I look at all my options, it looks like they're all divided into fourths or quarters too. So I just need to go over 3 out of the 4. 1, 2, 3. And then I'm supposed to go down 1.5. So halfway between the 1 and the 2. This is where your finger should be. Okay, try the orange one and then unpause it when you think you have it. So pause first. Okay, -2. So go backwards to 2. And then 75 cents is 3/4. 1, 2, 3. So I'm all the way to the edge. And then I'm supposed to go down to and 1/4, because 25 cents is 1/4. Your orange should be right there. Okay, try green, pause it, and then come back. Green, you go over 0, and then you go up 2 and 1 out of the 4 tick marks. That's where that one should be. And blue, you are going to pause and then come back. Okay, blue is going backwards 1 whole and then going 75 cents. So 1, 2, 3/4. And then I get to go up to a 2. That is where your blue dot should be. So graphing irrational numbers is a very difficult skill, but it is a part of the 6th grade content. So it's something that we have to learn how to do. It's still based on going over first, then up or down, but you have to know how to count the tick marks to figure out how many pieces make up the whole. So if you're still iffy on just plain graphing, make sure you go back and rewatch the lesson from last week. I will show you exactly where it is. So if you go to your Canvas page, today's lesson is right here, 2.4, graphing on the coordinate plane, continued. If you scroll down a little bit, we have lesson 2.4, graphing, and if you click there, this is last week's, it will have the recorded lesson from last week that teaches the basic graphing right here. Okay, click here for the recorded lesson. Don't forget, there are also resource pages that will teach you how to graph. Okay, resources, coordinate plane visuals and videos. Resources, coordinate plane visuals and videos. Poke around in your Canvas page to help you. All right, your assignment is in Solvus Realize. It's in Solvus Realize, and it is over 2.4, graphing rational numbers. Bye.